On behalf of RBCS, welcome to today's webinar on verification and validation. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their testing and quality assurance practices. I'm the author of many books on software testing, as well as being the past president of the ISTQB and the ASTQB. Attendance at today's webinar earns PMI PDUs. Thank you, Rex Price, for reviewing the materials for PDU status and for making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Before we start, a couple notes. If you have any questions during the course of the webinar, feel free to submit them at any time via your GoToWebinar interface, but please note that they are answered only at the end. There is no need to ask for presentation copies. The presentation is posted on the web. Go to rbcs-us.com and do a search for validation or verification and validation, and you will find the slide location there. By attending this webinar, you are automatically registered for the free e-learning drawing. Check your email over the next couple days and watch the spam filter. Hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not-just-for-profit company. Okay, so verification and validation. What are they, and why do they matter? So sometimes you'll hear people use these words interchangeably. People talk about verification or verifying, validation or validating, as if there were no distinction between them, no important difference. Which is unfortunate because there is an important difference, an important distinction that needs to be made to make sure that we don't miss out on important areas of testing. Now, there also have been some people lately who have decided to make up new names for these well-established concepts, and I'm not going to inadvertently promote those rechristenings of these two practices by sharing those names, which you probably know what I'm referring to if you're familiar with it. That's not helpful when people put new names on things that are already out there. For example, when the Delphic Oracle estimation technique, which has been around since World War II, was rebranded as planning poker without attribution to the Delphic Oracle technique, it simply divorced that planning poker technique from a lot of well-established best practices related to Delphic Oracle estimation that would otherwise have been pulled in by induction into Agile estimation. So all that putting new names on existing concepts does is confuse people who are not familiar with the original concepts. So you might have been wondering what's up with the cover painting on the front. Usually there's some sort of little graphical pun or metaphor there on these cover paintings on there, cover pictures on my presentation. So in this case, go back to that. Extra points for any of you who can identify who the artist is, and even more points if you know the actual name of the painting. Anyway, what this woman is doing is verifying the weight of the jewelry in the scale, but she's also validating the appearance, the beauty of the jewelry with her eyes. You see that? She's looking, if you look at the way her eyes are pointed, her eyes are not pointed so much at the scale itself and to see whether or not it's balanced, but also looking at the objects that are being held in the scale. I see that a couple of you have already guessed the artist. I'll give you a good pat on the back for those of you who got it right at the end. So she is both verifying and validating, verifying that the jewelry weighs what it should, and validating that it is beautiful, that it is It is actually an attractive piece of jewelry. Both of these activities, verification and validation, are important parts of testing, and if you're missing either one of them, then you're going to end up not testing certain things that are important. So we're going to look at the use of these different techniques, verification, validation, or at least these concepts that apply to different kinds of testing techniques, and talk about how to achieve the appropriate balance. So first off, what exactly do I mean by verification, and what do I mean by validation? Well, one useful way of thinking about these two terms is in light of two of the most important definitions of quality. So Phil Crosby's definition of quality in his book Quality is Free is conformance to requirements. And sometimes people say, you know, the way to think about verification is to ask, you're asking yourself, did we build the thing right? Did we build the thing properly? The thing being the software, the system, etc. So according to our predefined specifications, that's verification. Now, validation is checking fitness for use, and this is like Duran's definition of quality, which is fitness for use, the presence of attributes, capabilities, and features that provide stakeholder satisfaction, and the absence of attributes, features, and behaviors that would result in stakeholder dissatisfaction, for example, bugs. So the way to think about validation is, did we build the right thing? So notice the difference there. Did we build the thing right? Did we follow established best practices in building the thing? That's verification. Did we build the right thing? Did the proper thing, the thing that was needed, the piece of software, the system, etc., come out of the end of the process? Now, another way of thinking of it is that if you're building what you, if you're checking whether you built what you said you'd build, then you can call that verification. If you're checking whether you built what you should have built, then you're validating. I'm reading those off the slides because it took me a while to come up with those formulations, and I wanted to get them just right. So again, if you're checking whether you built what you said you'd build, you're verifying. And if you're checking whether you built what you should have built, you're validating. Now, some people might say, okay, well, does that mean that like verification is positive tests and validation is negative tests? Happy path versus, throwing junk at it? No, that's both verification and validation can include both positive and negative tests. So that's not that same distinction as inputs that should be accepted and processed properly versus inputs that should be detected as invalid and rejected, which is the positive versus negative test. That's a different distinction. And if that's not clear, then during the Q&A session towards the end of the presentation, let's discuss that further, but those are different. All right, so those are a couple working definitions. Now, some of you might be familiar with the ISTQB definitions, which come from the ISO 9000 standard. And you look at them here, and we have verification, confirmation by examination through provision of objective evidence that specified requirements have been fulfilled. And validation is confirmation by examination and through provision of objective evidence that the requirements for a specific intended use or application have been fulfilled. So, you know, it's like, whoa, that's quite the word salad there. You know, how do we detangle that? Well, one way to do that is to look at what's common and what's different. So I've italicized the common stuff and underlined the differences. And so if you look at the differences, basically verification there, specified requirements have been fulfilled. So that's conformance to specifications. And the second one for validation there, requirements for a specific intended use or application have been fulfilled. That's fitness for use. So, you know, it's a somewhat more cumbersome way of expressing what I had on the previous slide. Now, the common stuff is what applies to either verification or validation, or to both of them. And it's what they call direct examination, which is basically you apply static and dynamic testing techniques, review, static analysis, black box tests, white box tests, experience-based tests, defect-based tests, to do your verification and validation. And then you have indirect examination, which would be I check that somebody else's testing is somebody else's verification and validation or testing has been done properly. Now, this definition allows for what's called independent verification and validation, which is something that's commonly used in defense industry, the defense industry, which is where a outside organization will go in and audit the contractor who's building the weapons system or other defense, procured defense item. And they're basically checked to make sure that that the testing done by that contractor, which is called developmental testing, has been done properly, thus kind of avoiding the fox and hen house problems that you would have. Now, let's look at some examples here of verification and validation. So let's say that you are doing acceptance test driven development. Okay? You're working in an Agile team, you're doing acceptance test driven development. You get user stories, you work with your product owner and developer colleagues to define good acceptance criteria for those user stories. You define acceptance test driven development test cases out of those user stories, and then you automate those. That's verification, because notice that the tests are flowing forth from the specification. They are basically derived from the specifications themselves. Now, let's suppose that you download a defect taxonomy from a reputable source online that is based on some research done on applications similar to the one you're building, common defects that have been seen in applications like the one you're building. And you go through and you use that defect taxonomy as a checklist to make sure that you don't have any of those bugs, or at least to try to reduce the likelihood that you have some of those bugs in your product. That's validation. So those are two examples. And they're just two examples. Obviously, there's more that I could give, but I wanted to give some concrete examples here at this point because we've been sort of in the definitional stew for a while, and it's a good idea to pop your head out of that and go, okay, that's all those words makes perfect sense to me, but show me. Again, if that's not sufficient, when we get to the Q&A session, throw some more activities at me, and I'll give you my take on, is it verification, is it validation, or is it maybe a little bit of both. These two examples are deliberately contrived to be basically pure 200 proof versions of either verification or validation. In many cases they are it's not so clear as to whether something is purely one or the other. It's usually more of one than the other, but often not entirely one rather than the other. So this gets to a point that I've raised down here in this slide later about the verification and validation being overlapping activities. So now you might say, well, how much blending tends to go on? Well, the better the specifications are, the better the specifications capture the intended use, yes? So better specifications are going to mean that there is more overlap between verification and validation. Whereas if the specifications are worse or entirely missing, then the validation is becoming more and more important. Now, why do I need both? Well, verification is going to be necessary because There is no one person who by him or herself is going to be the perfect oracle, as it were, the perfect test oracle, the perfect person able to look at that and something and say, that will work, you know. So no matter who we get collectively to do the testing, if we have no reference points about, well, what is it that this thing is supposed to be, then the validation itself will be incomplete and in many cases contradictory. But let's say we do have a requirement specification, and we say, well, shouldn't that requirement specification perfectly capture all of the intended uses? Well, no. Certainly, you know, nobody has ever said to me in any context, and this is, you know, talking to hundreds of thousands of testers around the world, nobody has ever said to me, oh, what do you mean requirements are a problem? I get perfect requirements every time, and they're always complete and unambiguous and without gaps, overlap, or contradictions, and they express everything about what the software should do. No one has ever said that to me. So, you know, that would be one thing if I'd only spoken to a couple hundred testers around the world, and or maybe a couple hundred testers in one country. And you could say, well, you know, okay, that's you know, a small sample, but I think having been to every industrialized continent, which means I've been every continent other than Antarctica, and penguins don't do software. So having been to every continent where there is a software industry and spoken to practitioners of software testing in the software industry, and have never had anybody say, yes, the requirements are always perfect, I think we can assume that the requirements are never going to be perfect. And I think there's probably an interesting sort of computer science computability question here as to whether the requirements ever actually could be perfect. Like, is it actually possible to completely specify the behavior of a software product using English language words? Probably an interesting PhD thesis in there somewhere. It kind of tickles my brain in terms of some stuff that I studied in my last year at UCLA related to computability and NP-complete problems and so forth. But whether it's an actual limitation, like it's actually impossible, scientifically impossible for the requirements to completely capture the behavior of software, or just that nobody ever bothers to do it, even though it is possible, doesn't matter, because from a testing point of view, it means that if you rely excessively on the requirements, you are relying on a faulty oracle indeed. Okay, so verification, validation, and different types of testing. So let's look at some of the different types of testing, and I'm for convenience sake, I'm using the terminology in the ISTQB glossary primarily here, just because it's a lingua franca, as it were, of software testing. If you call these things by different names, you know, that's fine. I'm just trying to keep it simple by using a common language that everybody can refer to. If you're like wondering, well, what exactly did he mean by one of these terms? If you just go to the ASTQB or ISTQB websites and search for the glossary, you can get the definitions of these. So static analysis, first test type to look at here would be things like taking a code analysis tool and running it against the code as it's being written to look for things like excessive complexity and violations of coding standards and best practices and so forth. I would consider that to be basically a form of verification, because it's checking against a predefined set of rules, which by adopting the tool you have effectively adopted as low-level specifications for your code, rules that it has to conform with. I could write code that was perfect from a static analysis point of view, and I mean absolutely perfect. No deviations, no reported warnings or errors from the static analysis tool, and it could be utterly unfit for use. Now, the code might be perfect, but it does exactly the wrong thing. Think of if I write the code for solitaire when what I was supposed to write was a poker game. The code itself could be perfect, but it could be utterly unfit for use. So it's a form of verification. Now, what about review? So review is a human activity. Primarily, the humans are going through the code or the requirements or the design specifications, the architecture, the database schemas, what have you, and the people are working together to evaluate those specifications of the implementation of them. User stories, that kind of thing. If you're doing user story grooming, that's a form of a review. Now, this can be a mix of both verification and validation, though usually what I recommend to clients is that they try to push as much of the verification into their static analysis tools as possible. So for example, rather than have people sit around in a code review and argue about indentation standards and commenting standards in code, just put that stuff in a static analysis tool that reads the code and says, look, you violated our agreed standards. Same thing with requirements. If you have a standard template for user stories that they all have to comply with, that should just be checked prior to the review through some sort of static analysis, and it should not be something that people spend time discussing in a review meeting. How about white box testing? Testing based on how the software is built, usually trying to achieve some level of coverage, such as statement coverage or branch coverage or API coverage or something like that. This, again, is usually going to be some form of verification, depending to some extent on how the expected results are derived. But for the most part, it's a form of verification, verifying that we've built the product right. And that's in the process of testing it, we have visited every executable statement. We've invoked every API type of relationship or object relationships. In the case of object-oriented programming, we've done the different branches. So it's a did we dot all our I's and cross our T's kind of thing, which is verification. Now, if we're talking about black box testing, whether we're talking about functional or non-functional types of tests, this is generally going to be a mix of both verification and validation. The less we have with respect to specifications, the more we're going to be relying on validation. If you don't have something written down, you can't really rely on that which isn't written down to help you test. Now, experience-based testing, so things like exploratory testing or James Whitaker's software attacks technique or Elizabeth Hendrickson's bug hunting heuristics, those are generally a form of validation. We're not relying as much on a written specification, so mostly it's about validation. However, there can be verification elements. For example, if you're looking at things like claims made about the product on the website or your competitors' products or those sort of things, there could be things there that could be construed as verification. Defect-based tests, like use of the defect taxonomies that I talked about before, that's generally going to be a form of validation, because defect taxonomies encapsulate sort of the anti-expectations that people have. If I can coin a phrase there, anti-expectation meaning something that someone would expect to happen, but it's not what they want to have happen. So that's kind of what the defect taxonomies tell us. And then dynamic analysis, looking at things like memory utilization, CPU utilization, so forth while tests are running, is neither verification or validation per se, unless we have specifications that talk about what level of resource utilization should be a limit at a certain level of load. But a lot of times these kind of dynamic analysis techniques would be used as a way of supporting both verification and validation. Now, the venerable V model here, the waterfall or sequential lifecycle model where all of the activities and work products associated with one phase are completed before the next phase starts, consists of a mix of verification and validation activities. So calling up the spotlight here. During requirements, design, and coding, there should be requirements reviews, design reviews, and code reviews, which, as I said, will contain both verification and validation elements. Ideally, as much as possible, the verification is pushed into various forms of static analysis on the requirements via, say, grammar, spelling and grammar checkers and so forth, and use of predefined templates and so on, static analysis on the code. Now, what's called horizontal and vertical traceability testing is another form of verification. So horizontal traceability testing is making sure that for every requirement specification element there exists one or more test cases that covers it. For every design specification element there exists one or more test cases that covers it. And for every statement and branch in the code, there exists a test that covers that statement and or that branch. So that's horizontal traceability. It's called horizontal traceability because we correlate a testing activity, the right side of the V, against a development activity. Now there's also what's called vertical traceability, which is where you make sure that for every requirement specification element, there exists something in the design that will cause that requirement to be implemented. And for every piece of code, we have the corresponding elements in the design. Now, when you do vertical traceability, you have to make sure that you're looking at this both ways, in sense of every requirement has one or more corresponding design elements, and every design element corresponds to one or more requirements. The reason for that is if you have design elements that don't correspond to requirements, you're basically getting into gold plating. You're building stuff that you didn't specify. And the same relationship exists between design and code. In a V model, typically you're going to have what are called phase exit reviews at the junction points of these arrows, which is where you make sure that all of the right things have been done. So that's checking the process, making sure that the process has been followed appropriately. So notice that verification does include process compliance checking as well as looking at the product itself. Now, it's important to make sure that you're clear on who does that, because this is a punji trap that testing teams can fall into, which is where they say, oh, well, my job is to do verification, and verification includes not only looking at the product but also looking at the process for compliance with the best practices within the process. Therefore, it is my job to tell other people how to do their job, which gets you into the quality cop, process cop kind of mentality, which is bad. So be careful to understand who owns those things like the phase exit reviews and who owns the external audits. Now, of course, there are going to be dynamic tests that are going to be created and executed at the component test, unit test, integration test, system test, acceptance test levels. Those can include verification elements, as well as, of course, including validation elements. You see here. Though, for the most part, the validation is going to happen at a system and acceptance level, because the unit test and the integration test in a sequential lifecycle model, you're not going to have enough there to really know whether it's actually fit for use. Notice that phase exit reviews can also include a validation component as well, particularly if we have the ability to look at some sort of prototypes or early feedback on prototypes and so forth from our users. So they're not just about process compliance. Now, for those of you who live in the Agile world, as many people do, let's look at verification and validation there. So certainly the user story design and code reviews would include both verification and validation elements. Again, I would encourage you to try to push as much verification into your static analysis as you can. Traceability is still important here. So don't build stuff that isn't part of the user story. Make sure that everything's in the user story is built. Make sure that you have tests for every acceptance criteria in the user story, which again, that's verification. And then your dynamic tests will include both verification and validation elements. Certainly the unit tests are very much focused on verification, and also feature verification tests, which are things like acceptance test-driven development, for example, behavior-driven development. I would consider those to be feature verification tests because they're verifying that specific features are being properly implemented as part of building the user stories. That's distinct from the ISTQB meaning of the phrase acceptance test, which would really refer more to acceptance of a complete system. For example, if we're using A/B testing at the end of each iteration to evaluate how people feel about the new features, that would be classic acceptance testing in the ISTQB terminology. Now, there's also what I would call feature acceptance testing, which would correspond to the product owner sitting down and doing a demo on the product towards the end of an iteration, which would also qualify as a form of validation. So, as you can see, verification and validation alive and well, regardless of life cycle. Just because they don't always get called by their proper names doesn't mean they're not happening. And this puts verification and validation in the context of Brian Merrick's famous testing quadrants. So he talked about supporting the team and evaluating the product, but if you read what he says about it and also read what Crispin and Gregory say about it in their book on Agile testing, you can see that support the team really is verification, and evaluate the product, and this is more obvious, is validation. So the quadrant 1 stuff, the automated unit tests and so forth that are going into your continuous integration framework, that's clearly verification. And then the quadrant 2 stuff, tests based on acceptance criteria, tests of epics and so forth, acceptance test-driven development, behavior-driven development, automated and manual. Again, mostly verification. Unit testing is more technology-oriented, and ATDD, BDD, and so forth are more business-oriented, but still both on the verification side of the quadrant. And then if you look at the quadrant 3 stuff, the manual tests, system tests, user acceptance tests, things like scenario testing, usability testing, exploratory testing, and so forth, that's all validation. And then the quadrant 4 stuff, the system test and operational acceptance test, types of things like reliability testing, performance testing, data migration, security, maintainability, compatibility, interoperability, those sort of things that are automated tests or tool-supported tests. Again, validation primarily, though, again, there's the business focus versus technology focus here. And, the quadrant draws sharp lines here as if it were possible to put things cleanly in one of these boxes or another, But as I said before, it's possible for tests to have elements of both validation and verification. And really you can have, there's a spectrum of this business orientation versus technology orientation as well. So, I think these kinds of quadrants and classifications and so forth can be useful as a way of clarifying your thinking about what you're doing, but they can also be harmful if you get so hung up on classifying that you don't pay attention to why you're doing what you're doing. And you get into one of these how many angels on the head of a pin kind of things. So nonetheless, I think that this is a good way to categorize the quadrants. I know that there's recently been some pushback on it, and even Merrick, who's Brian, I like Brian. I've known him for years. The guy is a real iconoclast, and give him an icon and he will break it, even if it's the icon that he made himself 15 years, 20 years before. So he sort of joined in on the bandwagon of critiquing this, but I think it's a useful way of thinking about test classifications, even if you're not in an Agile world. Now, another model that came out of the Agile world, which again is useful, though, as with all models, potentially misleading or confusing, is the classic, what's called test pyramid. I am not sure, well, I do not remember who came up with this. The first time I think I saw it was a few years after Agile started being talked about pretty widely, early 2000s. And of course it's in Crispin and Gregory's book and properly accredited to the creator there, but again, I don't remember who came up with it. But the basic idea, which is shown on the leftmost of the triangles here, is that the bulk of the testing should be unit testing, and then do some integration testing, and then have some system level and acceptance level testing at the UI. I think that's a useful way of thinking about it. If you basically say to yourself, okay, my idea is to achieve what's referred to as phase containment, which is the detection and removal of a defect in the same phase in which it was introduced. Now, phase here can be a little misleading, because if you think sequential life cycles, then you get kind of caught up on phases as meant in a sequential life cycle. But if you're in Agile, basically what that would mean is that if there's a defect that's introduced into a user story and it's not detected and removed during user story grooming, that's an escape. If there's a defect introduced in coding and it's not detected and removed until the product owner is doing their feature acceptance test at the end of the iteration, that's also an escape. It's escaped from the phase of introduction through succeeding phases, and thus the cost of detecting and removing it has gone up. So from a way of kind of metaphorically thinking about trying to shift the focus of testing towards the point of defect introduction, I think that the testing pyramid is good. Now, there are some problems with it. One problem with it is when people take it literally. And I run into people saying, well, I have, say just, numbers here, made up numbers. I have 20,000 automated unit tests, and I have 2,000 automated feature acceptance tests that are part of our continuous integration framework. And then I have 200 automated Selenium tests. So I'm, perfectly doing the testing triangle here, a testing pyramid, excuse me. And I would say, well, really, because the units are completely different. What I mean by units, I mean like units in the sense of Fahrenheit versus Celsius, miles versus kilometers. When you're comparing test case counts, the number of test cases, when tests are implemented differently and are covering different things, those numbers are actually meaningless. So that's one of the problems with the testing pyramid, is that it kind of gets you, it can set people on a path of doing something that is mathematically invalid and misleading, and it results in confusion. So that's one of the things that you need to keep in mind about the testing pyramid. Now, another thing is something I picked up from Christian Karl in his presentation at the Test Istanbul conference earlier this week. And he had a number of different forms of the test pyramids, and he said, well, if you want to look at business logic coverage, testing through the UI, you're really doing a lot more from a validation and business logic point of view, and you're doing a lot less of that if you're down at the unit testing level, right? So unit testing type of stuff, high code coverage versus automated UI tests, which generally achieve very low code coverage. So I've done some experimenting with this and talking to people, and you look at system tests, automated and manual system tests that are devised using primarily black box techniques, and you go and you measure the code coverage, usually it's going to be somewhere around 20%. So pretty low compared to what you would want for automated unit tests, which would be 100% statement and branch coverage. And then, of course, the execution time and costs. This is something that you definitely want to look at too. That the more testing you do at the system acceptance test level, especially through a user interface, the more expensive that's going to get. So that's again another reason to try to get the discovery of the defects as close as possible to the point of introduction, because not only is it cheaper to remove the defects, but it's going to be what's sometimes called the cost of appraisal, or the cost of detection, is going to be a lot less. But as you can see here again with the testing pyramids, a relationship between the testing pyramids and these concepts of verification and validation. Now, how about with testing strategies? What's the relationship between verification, validation, and testing strategies? Is there one? Yes, there is. So if you think about something like analytical requirements-based testing strategies, where you analyze the requirements to create tests to cover the requirements, obviously that's a very heavy verification piece. But you can also be doing analytical risk-based testing, which is primarily, at least if done properly, an outcome of discussions with the stakeholders about what you're worried could be wrong with the product. And so if you're doing that, then that is a form of validation. Again, those are sort of the anti-expectations. Now, how about model-based? Well, if the model that is used to develop the tests is part of the specification or derived from the specification, like, say, a state transition diagram for the way a application interacts with the users, and that's fed directly into some sort of tool, which then does the generation and execution of the tests, which is classic functional model-based testing, then that's pure verification. But there can also be validation here. So, for example, when you do performance testing of servers, many times you're going to look at logs of what kind of traffic you're actually getting into that server, and then you use that to build up your models for the usage of the server, and you try to simulate those using load generators. Again, this is validation, because you're looking at observed or predicted usage, so it's about measuring fitness for use. Now, how about methodical testing strategies, where we are following a checklist of some kind or another? Well, if the checklist is part of the specification, then certainly that can be considered a form of verification. But many times these checklists are going to reflect some sort of user expectation or need. So, for example, Jakob Nielsen wrote a book on usability engineering that can be summarized as a checklist, and I've got this checklist in my Advanced Test Analyst course, I believe, which is pretty easy to explain. It's based, it's summarization of the precepts laid out in that book, and that could be given to a tester. That checklist could be given to a tester, and the tester told, as you go through each screen and as you look at each field on the screen and as you experience transitions between screens, refer to this checklist to look at the usability of our UI. And this is not explicitly part of a specification, but it's the book, Nielsen's material in the book is obtained basically from his years of experience as a usability engineer and as a consultant working in the field of usability. So it's validation. Now, process and standard compliance, can be a mix of both verification and validation. Kind of depends on what process we're talking about. I mentioned this Agile and how it includes both verification and validation elements. CMMI explicitly has verification and validation as key process areas in level 3, if I'm remembering right. And the FDA guidelines and the FAA guidelines also include both verification and validation elements. Now, reactive testing, which is what you're doing when you're doing an exploratory type of test or using Whitaker's attacks techniques and so forth, that is almost entirely validation, as I mentioned before. Consultative or directive strategies where somebody else gives you the list of conditions to cover, kind of depends on how much direction you're given and where those conditions came from. So, for example, let's suppose that you are doing compatibility testing across a predetermined set of mobile devices, and you're given that list of mobile devices and given the app by the app maker, and you're told, hey, I want you to make sure that my app works on these different mobile devices, and doesn't tell you anything about how specifically to check that, and you just go off and go, well, I figure out what I think this app is supposed to do, and then I'm going to try that out on the different supported devices. That's going to be primarily a form of validation. Now, let's suppose that in addition to giving you the list of supported devices in the app maker also gives you a set of use cases and says that, well, I want you to verify that each of these use cases can be carried out. Now you've added a very strong verification element to that, because the use cases are a specification of the system, but the use cases are also, interestingly enough, a specification of intended use. So use cases, when you're testing against use cases, there's usually both a verification and a validation element. And then finally, you have regression-averse testing strategies where you're doing a lot of automation. So, for example, test-driven development, where all the tests are created using a harness like JUnit or CPP unit and then put into a continuous integration framework and rerun, and combined with other things like ATDD tests and Selenium tests and so forth. Usually all of those tests are following out of some sort of set of requirements, and so it's very much verification, not really very much validation. Okay, so to wind this up, some conclusions here. As I said at the outset, please don't make up new names or promulgate made-up new names for concepts that have already been well established. We have enough of a Tower of Babel problem in this industry where people call the same things by different names and use the same names for different things. If you look at other more mature forms of engineering, one of the things that they have is a well-established glossary, a well-established way of communicating about things. I mean, everybody in electrical engineering agrees on what an ohm is, and they agree on what resistance is. And they don't have to have arguments about what is resistance and what is an ohm. The sooner we can get to that place with software engineering, the sooner we're going to get more mature as a profession. Now, I don't really have any sort of emotional stake in where we ultimately coalesce. If we ultimately coalesce on the ISTQB glossary, that's fine. If we ultimately coalesce on something that's close to it, that's fine too. And if we ultimately coalesce on something that's a long way from the ISTQB glossary as it currently stands, that's also fine with me, but we should coalesce. And we should not be making up new names for things that already have existing names and are well understood, because it just confuses people. So with that said, I mean, we looked at verification and validation and what they are, their different goals and their different areas of focus. As I said, they are partially overlapping, so attempting to, very clearly and unambiguously classify an activity as one or the other may well fail, and that's not a problem. That's just because it includes elements of both. Automation can be used for both, though usually verification is the one that's more susceptible to automation. We looked at the different strategies and the different types of testing that are out there, and as you can see that there are elements of both in the different types and strategies, though some of the test types are more purely one than the other. As you see, this verification and validation is not, contrary to some people's assertions, a V model thing or a waterfall thing or not Agile, but certainly as relevant in Agile as in any other life cycle. And hopefully this has given you some reason to believe that both of these are essential to good testing. So it's important to know how to apply both of these in your testing efforts to be ready to blend verification and validation appropriately and deploy them at the right time, in the right ways, with the right blend of automation and manual testing to optimize the extent to which you achieve the goals of testing, which namely are typically things like finding bugs and building confidence and reducing risk of failure in production and providing people with the information they need to make an intelligent release decision. All right, so I'll go ahead and put the advertisement up here. And we'll start plowing through the questions. Somebody asked me at the beginning of the presentation, will this presentation be available on the website later? He says, I have a work meeting and won't be able to attend. And as many of you probably know, a recorded version of this webinar is going to be posted, and so it's usually posted within a week or less of the live sessions. But important to keep in mind, you can only win the free e-learning drawing if you attended the live presentation. You can't just by registering, you don't get put in for the drawing. You actually have to be one of the attendees according to GoToWebinar, and we get an attendee report. In addition, because of the rules of PMI, these are not our rules, these are PMI's rules. If you want to claim PDUs, you can only do that for live presentation because, again, we can only provide proof that you actually attended and listened if you did attend. Wow, okay, so Bill, so I got Bill and I got Rob. No, so Rob says the painting is by Vermeer, which, let's just go back here. And Rob is right, that is indeed a Vermeer. It is, for those of you who are sort of art aficionados to some extent, and I've spent a lot of time when I travel to Europe wandering around art museums. Vermeer is pretty much instantly recognizable if you've seen a few of his. So yeah, it is a Vermeer. But then Bill beats Rob both in timing, he was 5 minutes earlier, and also in detail by saying, this is Vermeer's Woman Holding a Balance, which is correct. That is exactly what it is. And it has a painting of the Last Judgment behind her, which it does. And I hadn't even noticed that before, and I think I've seen this painting in the flesh, as it were. I've been in the museum where this is. He says, Bill says, are you suggesting the software testers are passing final judgment with their verification and validation, or if bugs slip by and what was built was not really suitable, then the QA folks will eventually face reckoning at their own last judgment? Neither of these, I would hope, Bill. But yeah, you definitely take the cake there. The last judgment piece was one that I had missed. Well, let's see. Harvey says has reported a loss of audio, but nobody else did. So Harvey, I hope you're back on. And then what probably happened was that you temporarily lost your connection to the internet, which because of the hub and spoke architecture of GoToWebinar, if a listener loses their connection to the internet, they alone lose their audio, versus if the speaker loses their connection to the internet, everybody loses the audio. See, Paul says, so basically if you release a product according to the specification, then this is verification. If the spec will not satisfy the customer needs, then this testing is validation. Okay, so if I test and the only thing I look at to derive my test is a written specification, then that would be classified primarily as verification. Though again, in the case where the specification includes a use case, since a use case is describing a particular way in which the user intends to use the product, then there is a validation element. But to the extent that the specifications do not fully capture the user or customer needs, there is a need for additional testing via validation, which is testing that's not focused on some specification, but testing is focused on what's the user trying to do with this thing anyway. Let's see. So Stefano asks, hi Rex, how do you consider usability testing? Usually it's the area where specifications lack the most. We do it mostly based on testers' experience on, quote, how our customers will use the software, end quote. And it often leads to negotiation with developers as issues we raise with respect to usability are not backed up by specifications. And he's saying here, and he's saying basically, Stefano is saying if the developers will say that if it's not specified, it's not a software bug, but rather a suggestion for improvements. With the problem being, he says, then our customers raise bug reports or report bugs in production. So yeah, I mean, I think, usability, performance, reliability are often underspecified, and so there's, when you're doing those kinds of non-functional tests, yeah, there's a strong validation element of that, because you're trying to figure out, well, what's the user's expectation going to be. So, what are usability best practices? Well, I mean, it really kind of depends on how have people's expectations been shaped. 15, 20 years ago, you talk about usability best practices and interaction between the user and the application, and it's all going to be mouse and keyboard and graphical user interface, and that was the state of the art. Those were the best practices available at that time. Now you look at mobile devices, and you've got the whole, the ability to manipulate the screen and rotate the phone or mobile device. That affects behavior, etc. So that's certainly evolving. So yes, that I would call validation. Interestingly, I think that when you're involved, if you're a programmer or a SDET, a software development engineer and test, and you're involved in code reviews and you're looking at the code and evaluating the goodness of the code from a maintainability perspective, that actually has some interesting validation elements in it as well, in the sense that if the code is not maintainable, it will regress over time, and people don't like it when you break stuff that you already gave them. Paul has pointed out one of my favorite phrases. He says, "You've mentioned quality cop in the past 2 webinars. Do you feel that the quality gates with respect to following process need to be done by bodies separate from the test team? Would a test manager perform this role?" So I actually did a webinar on this, which maybe I need to do again, because I use these phrases quality cop and process cop fairly frequently, and I probably need to do that webinar again just to make sure that everybody's clear on what I mean. Let me make a note here. I'm making a note to reschedule a repeat of that sometime later this year or early next. So who should own enforcing adherence to process? So I think, a person in an Agile world would say, well, that's the Scrum Master, or it's the whole team owns the process. Nobody that I know of would say that's the test manager's job in an Agile organization. And I'd be happy that they wouldn't say that, because it is a thankless job. So it's good to have somebody else own that particular problem. In an Agile, in a sequential lifecycle model world, certainly I have seen that being owned by the testing organizations. I've not seen that work out well for them. Personally, I would think that process adherence, if you're in a sequential lifecycle kind of world, that ought to be owned by the project manager and or the PMO, project management office. I just think that it puts the test manager in a difficult position when not only is he or she the conduit for information about how someone failed to build what they should have built, they're also critiquing the way that they built what they built, which I think is just fraught with difficulties. I mean, and just picture yourself going home to your significant other who has baked you your favorite meal, and as opposed to saying, why, thank you, that's lovely, that was so thoughtful, you start off by going, well, you burned the crust, the cheese doesn't look quite right, there's too much spice in this, and then you ladle on top of that. What do you mean you put it in the microwave? You're not supposed to do it in the microwave. You're supposed to do it in the oven. I mean, it's just fraught enough as it is to deliver a critique of the product, and without adding into that, oh, and by the way, you're doing it wrong. So I would really, prefer that be somebody else that owns that process cop stuff. Taz, my man, it's got me on the on my question of who created the test pyramid, and Taz says, and he provides a URL, which I will forward on to everybody. Well, at least I think I will. I'll actually send Taz's response here too. Oops. I'm going to try to send Taz's response. So Taz is saying that this is from Martin Fowler, according to Martin Fowler. Test pyramid is a concept developed by Mike Cohn, described in his book Succeeding with Agile. And now that you say that, Taz, that does indeed ring a bell with me, that is a Mike Cohn thing. So I criticized Cohn for rebranding the Delphic Oracle estimation technique as planning poker, and that may be unfair in that. I didn't actually criticize Cohn directly because I'm not sure that he was the one who did it. I do know that he's one who has profited on it quite a bit by selling planning poker cards, but that might have been somebody else who came up with it. But certainly testing pyramid is something that I think is useful. Well, as I said, the rebranding of the Delphic Oracle estimation technique as planning poker did not contribute to the advancement of the software engineering profession. Let's see. Paul says, would reactive testing be where you're basing your tests on a vague requirement or risk? Oh, would reactive testing, where you're basing it on a vague requirement or risk, etc., be verification? To the extent that you are looking at some sort of requirement or other specification, user story, use case, then you are introducing a verification element into your exploratory testing. Yeah, your reactive testing. And, some people would say, well, if I'm looking at claims made about my app or my product in the company website, well, that's also a form of specification, so then I'm back to verification, and okay, I guess I'd buy that. I guess the thing that I would be concerned about is, don't get too caught up in trying to get all, either or, black and white on these classifications, because stuff will sort of fool you. And Paul, you just provided some good examples of that, where it's, neither fish nor fowl, as the saying goes. Keith says, thank you, Rex. These fundamental test concepts are always worth reviewing. Yep, thanks for saying that, Keith. I feel the same way. I got the inspiration for this, as you could probably tell from the outset, was this latest tirade or Twitter storm about, verification isn't really testing, it's checking, and there was just so much silliness there. I was like, okay, this clearly requires a response, and not one in 140 characters. So yeah, I just wanted to get this fundamental ideas back out there, and also for to make sure that people see that they're still relevant, because there's been a lot of that sort of historical revisionism about, well, we're Agile, so none of that stuff applies to us. Let's see. Tracy says, within user stories there are acceptance criteria. They may or may not be related to requirements, but the user story cannot be closed without them being complete. Verification or validation. See, I would consider tests that are derived from the acceptance criteria within a user story to be primarily a verification, because that's we're making sure that, okay, what we said it was going to do, it does. Now, could there be validation elements to that? Yeah, you bet. Harvey confirms that he was good. His audio problem went away. Glad to hear that. Michelle says, it has been traditionally stated that finding defects later in a program is more expensive. Recent white papers have questioned this. What are your thoughts? So I haven't actually looked at any of these white papers. I mean, everything that I have seen, every study that I have seen, all the industry figures from people like Capers-Jones, for example, point to there being an increase. And so every reputable piece of data that I've seen shows that there's an increase in cost on average as time goes by with defects from their initial introduction to their ultimate discovery and removal. The exact amount of that increase varies depending on which study you're looking at, and I think that's probably That does not impeach the credibility of the studies in my mind, because the economic and business factors are going to vary so much from one organization to the next that that's going to yield different numbers. But the basic idea that the cost is increasing is one that I've not seen refuted in what I would consider a credible source. Now, is it possible that one could point out examples of defects that, when found later, would actually be cheaper than if they had been found earlier in terms of cost of removal? Absolutely, because what is being discussed here in terms of the discovery and removal of defects increasing over time is the average cost of discovery and removal. Obviously, you're going to have a distribution there, a distribution of costs. And by looking at any single bug, you could find differences. Just like, if you got the temperature of water, you got a cup of water, say, right? And you measure the temperature of water. Well, the temperature is basically a measurement of the motion of the molecules within the water, right? I mean, how agitated they are, how much energy they have, and how they're moving around. And as the temperature increases, the amount of motion in the molecules in the cup of water is increasing. But you can't then try to predict the velocity of any one molecule of water from that, right? And I think if the critique that's getting tossed at this well-established industry belief that the cost of detecting and removing bugs goes up the longer they're around is a critique based on finding a few exceptions and going, look, I've disproved a scientific rule, then that just indicates a basic misunderstanding of what that rule says. So I certainly look at that if you want to forward on some of those papers, but I would guess that there's some sort of misunderstanding of what the point of the rule is. The point of the rule is not that every defect inexorably increases in cost to detect and remove from the moment of introduction onwards, because that's not what that says at all. What it says is that on average over time, the cost of detection and removal of defects goes up. Let's see. Debbie says, we derive our validation testing from customer-facing technical requirements. For those requirements, we do both verification and validation testing from the technical requirements. So yeah, I mean, if the more the requirements reflect what the customer intends to do with them, for example, use cases, the more there is a validation element to the testing that's being done. But it's honest. It's going to be on a spectrum here. But I would again caution that no set of written requirements is going to perfectly capture the behavior of the software and the way in which it can be used. So, I think you want to have things that are explicit and deliberately pure validation, or as close to pure validation as you can get. Lynn Ann says, your earlier comments were interesting regarding usability. It seems like many of the ILIDs are unwritten requirements and maybe part of the validation realm. Maybe a future webinar on the ILIDs. Yeah, this phrase, the ILIDs, is something that I usually refer to as the non-functional behaviors. So you're talking about things like performance and reliability and usability, portability to some extent. And yes, those do tend to be underspecified, and as a result, there's a lot of challenges and a lot of sort of validation leaps that need to be made by the testers to figure out, well, what is somebody actually going to do with this thing? So As far as future webinars on that specifically, I'll certainly think about that. It's an interesting concept. I'll try to come up with something that's that would fit in there. Now, usually though, and I do, when I'm discussing testing, I'm not actually making a strong distinction there. I'm trying to pull all those things in, but certainly it's the case that those can be underemphasized. Now I've got a person here, Yolanda, who has her hand up, but I can't see what the question is that she wants to ask. Yolanda, if you would like to submit a question, I'd be happy to answer it, but with the hand raised, I don't know what your question is, and it has to come in through the Q&A interface. Okay, well, it looks like we've reached that time. We are done. So to close the session, a little bit more about the resources available through RBCS. Free webinar sessions once a month. Sign up rbcs-us.com. You can navigate to the upcoming webinars page and sign up there. You want a special webinar presentation for your company only of this webinar or on any other topic related to software testing, contact us, info@rbcs-us.com. If you don't get our free regular newsletter, sign up. Again, rbcs-us.com. Signing up will get you valuable discounts on consulting and training services, and also a regular newsletter that features a article about software testing and quality and news about what RBCS and its partners are doing lately. You can see all of our coordinates there on Twitter and Facebook and LinkedIn, so you can follow us there. Do remember to check your email over the next couple days because you might be the lucky winner of a free e-learning course from RBCS. You were registered for a random drawing for that course just by attending this free event. The blog is back, so if you go to rbcs-us.com/blog, you can read there on the blog, and usually we're still kind of tinkering with it, seeing what kind of take-up we get with it. When I post something there, I also post it on our Facebook page, so if you want to comment, just comment on the Facebook page, the RBCS Facebook page. Remember that the recordings of these webinars, along with a bunch of podcasts and videos, are available on our digital library. Also on iTunes, there's RBCS Podcast, and then there's the RBCS YouTube channel. So there's just all sorts of great stuff out there. We offer these free resources as a service to the software testing community because at RBCS we are a not-just-for-profit company. Before I shut us down here, Bill comes back, a very sad story. Bill says, I lost audio for a while during early Q&A. Did you answer my silly question about Vermeer? Well, Bill, I was actually singing your praises because not only did you know the painting, the artist, you knew the painting, and you caught a detail related to the Last Judgment in the painting in the background, which I had never noticed looking at it, which was brilliant, and asked whether we were the final judgment or whether we were setting ourselves up for the final judgment, and my answer to that, Bill, was I would hope that it would be neither. So yes, you definitely won the prize there. Rob, who's still on, got second place with that. He did correctly identify the artist as Vermeer, so that was good. So anyway, thanks to everyone for participating. This concludes the webinar. Look forward to seeing you on future webinars.